Hey guys, so in the last lecture we have seen carburation process and various air fuel ratio requirement for various different loads. That is for maximum power, that is 13 is to 1, and for maximum efficiency it is 17. So requirement for different loads and speeds. So in today's lecture we are going to see simple carburetor and its working and its types of carburetors. This simple carburetor is a very important topic. It has been asked in GTU exam many times. So we will see what is the construction working of simple carburetor. First, uh, let me draw a diagram. So let me draw a tube first. So this is a tube from where the fuel is flowing, and this is going towards the cylinder. This engine cylinder. So this is the engine cylinder. This is the spark plug. So this is the spark plug here, and these are the valves. So these are the valves here. These are the valves. This is uh, inlet valve. This is inlet valve, and this is the exit valve. This is the cylinder. This is the piston. This is the piston, and this is the rod. Piston, cylinder, inlet valve, spark plug, and this exit valve, outlet valve. This is the intake manifold. This is called intake manifold. This is called Venturi tube. Venturi tube. You can call it Venturi tube. This is the Venturi tube. So you must have heard the Venturi meter. So it's similar to the Venturi tube. So here, as you know, there is Venturi meter. There is a blockage which increase the speed of uh, this flow. So this is called Venturi. So this is the Venturi. This is the Venturi, and here to control the flow of the fuel, we are using a choke valve. So you must have seen a choke in your two-wheeler that is used to increase or decrease the flow of the fuel. So this choke valve can rotate in 360 degree, and it can block the passage of the flow of the fuel uh, in up to some extent, and it can increase the flow of the fuel by getting it vertical. So this is the choke valve. So generally it is in vertical horizontal form, but if you want to increase, then you can increase here. So here uh, here there is an inlet of the air from here. So there is an inlet of air from the air filter. Now where is the fuel? So from where fuel is entering? So basically fuel is entering from a nozzle here. So let me draw a nozzle. So fuel is entering from a nozzle. So this is the fuel nozzle. So this is the fuel nozzle, and here there is another valve, that is the throttle valve. So to same so from here, as you can know, that you can only control the air intake from here because there is no fuel, but from here you can control the air and fuel mixture. That is the charge you can control from the throttle valve. So this is throttle valve. So from here you can control the increase or decrease of the charge. So now this fuel is coming from a tank. So that tank, I am drawing that tank. So that is this tank can be your engine sorry your moped tank. So it is open to the atmosphere a little bit to mix the fuel with the air. So this is open to atmosphere. So from here, the fuel from the fuel tanks comes here to the float chamber. So this is not the whole tank. This is just a float chamber. So this is a float chamber, and from tank it is coming to this float chamber. So this is the float chamber, and from tank it is coming to this float chamber. So it is coming from tank to the float chamber. Now as you can see in this float chamber, why this is required. So suppose the fuel uh, is is at this level. So the fuel is at this level, and this is the needle wall. So this will be a needle wall, and IDDL needle wall, and this is the float, and this is the float chamber, and this is the float chamber, and this is open to the atmosphere. So this is the basically whole diagram. So let's now see. So this figure will give nearly a constant air fuel mixture. So it consists of a float chamber, needle wall, and fuel nozzle. So during the suction, during the suction stroke, air at the inlet, air filter. So during the suction, the air at the air inlet from the air filter having atmospheric pressure, and in cylinder there is a vacuum. So there is a vacuum. So air will enter from the air filter towards the cylinder, because there is a pressure difference over here. So vacuum is created in this intake manifold, and in air filter air is at atmospheric pressure, and intake manifold there is a vacuum. So due to this pressure difference, the air sucks from the air filter to Venturi tube. So this is the Venturi tube of the carburetor through the choke valve. So this is the choke valve here. So when airflow through Venturi, its velocity increases and pressure decreases. So when air is moving, so the velocity will increase, the pressure will decrease. Due to the reduced cross section at the Venturi, pressure in the float chamber is at atmospheric pressure, and the Venturi is low. So therefore the fuel will transfer to a fuel nozzle which is located at a height z. So here the fuel, so the distance between this and this is z. So fuel will transfer due to pressure difference, and it will move above height z, above the level of the fuel in the float chamber, and the lip height z is provided in order to prevent the leakage of the fuel when engine is not working. So in float chamber, the level of the fuel is always maintained constant by float and needle valve. So as fuel decreases, the float moves down. So inlet passage open the needle valve. So float will move down. So inlet passage will open the needle valve, and the fuel comes into the float chamber. So this needle valve helps in opening and the closing uh, of the this pipe, or from where the fuel is flowing. So so the fuel comes into the float chamber. When the float chamber is full with fuel, the float will stop the supply of the fuel. So the diameter of the fuel nozzle, so this diameter here, and the Venturi tube is designed that it provides nearly stoichiometric mixture at different position of throttle valve. So at this different position of the throttle valve. In normal working, choke valve is fully open, but during starting, the choke valve is partially closed, which restrict the airflow. So the during starting, the rich mixture is available. So when you start your moped two-wheeler, so when you open the choke valve, so what it does is that uh, it closes the entry of the air so that more fuel can flow towards it. So this is the function of the choke valve. So during starting, the rich mixture is available by the controlling the air supply. The throttle valve control the supply of the mixture at various load conditions. So quantity of the of mixture can be varied by throttle valve for different load conditions. That's why petrol engines are known as quantity governing engines. So this is basically the simple carburetor system and it's working. Now we will see the modern carburetor that, that are being used in today's engines, that is in today's world. So the various carburetors used in today's times is very complex, are very complex. So we'll see one by one. So just tilt your phone because now we are going to see a horizontal view. So let's start with first, that is Solex Carburetor. But as I said, these are the modern carburetors. So these are modern carburetors. So mixture requirement for stationary engines, as we know that, is almost fixed. But in automobile engines, mixture requirement is different for different operating conditions like idling, starting, normal, cruising, running, acceleration, high power, etc. So different operating conditions, air fuel ratio will be different in modern carburetor. So the mass flow rate of uh, air or fueled air depends upon constant cross sectional area, density and pressure difference. So mass flow rate mf is proportional to area, density of fuel and pressure difference. So this is for mass flow rate of fuel. Similarly, mass flow rate of air also depend on area. This is the area of fuel, density of fuel, area of air, density of air and pressure difference. So in some carburetor, fuel and air supply varied as a pressure difference changes with engine speed. So this carburetor are known as constant choke or constant Venturi type carburetor. So few carburetors will be called constant choke and constant Venturi because the fuel and air supply varied as a pressure difference changes with the engine speed. Now in SU carburetor, that is Solex. So in SU carburetor, so it's a type of a carburetor. Pressure difference, that is delta B, remains constant, but area of fuel and area of air will varies to change the mass of mass flow rate of fuel and mass flow rate of air. So this carburetor is known as constant vacuum. So there are two types. That is, first is constant choke choke or constant Venturi, or you can call Venturi, and another is constant vacuum. Now in constant vacuum, this the carburetor comes as SU carburetor, while in constant choke and constant Venturi, the carburetor comes as Zenith, Solex and Carter. So we are going to study four types of carburetor, four different types of carburetor. So we will start with first, that is Solex carburetor. So let's start with first carburetor, that is Solex carburetor. Now just tilt your screen to understand in a better way. So in Solex carburetor is shown in this figure here. So as you can see, so this Solex carburetor has additional features compared to the simple carburetor. So Let's start with starting. So to get rich mixture during the starting, a bi-starter disc. So a bi-starter disc is used which operated manually by starter level. So here a disc is used which is operated by a manual level. So a bi-starter disc consists of different size of hole. So at the time of starting, the starter lever pull, which will rotate the bi-starter disc so large of hole open, through which more amount of additional fuel supply directly below the throttle valve. By this action, a rich mixture available during the starting as the engine is warm up, slowly starter level push back whole size of the bi-starter disc, and which will reduce the quantity of the additional fuel. So as here you can see that for starting here the so as you can see that the for starting the fuel has been thrown it has been added below the throttle valve. So as you can see from here the fuel is injected to increase the rich mixture here. So that is the for starting. Then the normal working. Now in normal working is similar to a simple carburetor. So metered fuel supply from the main jet here. So this is the from as you can see that this is the main jet. So from here the metered fuel supply from the main jet inside the Venturi tube. So it moves inside the Venturi tube and air enters from the top. So air is entering from the top and the fuel is entering from the bottom here. So air is entering from the top and passes through the Venturi. So it passes through the Venturi where it mixes with the fuel. So it mixes with the fuel here. So this is the main Venturi. So this is the main Venturi and this is the buster Venturi. So the fuel flows from here to here and also uh, also from here. So this is the main Venturi and this is the buster Venturi. So there are two Venturi here. So uh, so from the main jet inside the Venturi tube and air enters from the top. So here the air and fuel gets mixed. So from here the air and fuel gets mixed and passes through the Venturi where it mixes with fuel according to the position of the throttle valve. So according to the position of the throttle valve, the quantity of the mixture is supplied to the engine. So what will be the throttle valve? So in the same way the fuel will be supplied. So idling and low load. During the idling and low load, during rich mixture is required at this requirement will be fulfilled by pilot jet. So this will be fulfilled by a accelerating jet. Uh, so sorry, that is required by pilot jet here. So as you can see here, so there is a pilot jet here. So this is the pilot or idling jet. So from here, the when the fuel moves from this pipe, so the fuel also moves through towards the bypass, that is pilot jet. So when there is an idling or low load condition, so more fuel is required. So as throttle valve is nearly closed, extra fuel will be injected from this pilot jet here. So extra fuel is injected through this ideal port. So some additional air is also added from the pilot air bleed orifice due to the suction at the idler port. So here you can see that the additional air is also added in the pilot jet so that you can mix the air and fuel. So as the speed increases by opening the throttle, pressure below the throttle valve decreases, so additional fuel supply through the idle port stops. So the additional fuel supply will stop here. Then there is an acceleration. So when there is an acceleration, so uh, during the acceleration it is required to inject additional fuel. So therefore an acceleration pump is provided for this purpose. So this is the accelerating pedal. So when you apply the accelerating pedal here, so what will happen, that more fuel will be flown. So pump lever will operate the acceleration pump here. So this is the accelerating valve here, which will inject the additional fuel. So it will inject the additional fuel inside the Venturi tube here with the help of the accelerating pump injector. So this is the accelerating jet. So this is for accelerator, this is for ideal, this is for starting. So this is the whole somewhat complex process of the Solex carburetor. So there are also few other carburetors which we'll see in the next lecture. So thank you very much.